Welcome to Complexity Made Simple. My name is Paul Allen, and the subject of today's video newsletter, well, we're going to take a look at regression. We're going to take a look at just simple regression, the power, effectively. What does it do? Well, it generates an equation. What's the power of generating an equation as opposed to just looking at pass-fail type knowledge, or indeed historical knowledge or experience, etc. Let's look at using regression to generate process knowledge instead of experience. And essentially, of course, if we talk about simple regression, we're going to go back and we are going to visit a simple equation that lots of us learned at school, and it's the equation for the straight line y equals mx plus c. Now this links in very nicely to the principles of Six Sigma, because what do x's represent? Well, they represent inputs. What will the y's? They will represent outputs. So inputs control outputs. So that links directly into the principles that we've already been using in Six Sigma. But think about the power of this over and above experience. Let's say you have a variable which you can adjust, and we'll say, well, I'm going to suggest that there's a scale with 100 choices. Let's say I'm going to suggest that maybe this is temperature. Let's pick something simple. So you're going to use temperature, and you'd like to know the effect of temperature on the hardness of the material that you're manufacturing or producing. Now, of course, what could you do? Well, you could use your experience and skill, and you could literally test or take a view of all 100 choices. Okay, now it's a way, but you'd have to do 100 different tests. That's a very slow way of learning anything, isn't it? Well, you could do this, look. You could do a test, of course, at the low. You could do a test at the high. You could create a prediction equation. So you create an equation using regression. What does it create? It creates a prediction equation. And then in order to prove that that equation is true, you would do what's known as a confirmation test, and usually you would do it at some kind of middle value, somewhere in the middle. Because if this thing is a straight line, which is what y equals mx plus c represents, if you pass through that red dot there, then clearly the equation is in play. And now look what we've done. Well, we've just done 3 tests. That's all we've done potentially. Or we've tested in 3 places. In reality, in order to make this work a little bit better, you might have collected a little subgroup at the high and the low point. But for a very small number of test points, I can now predict 100 choices. I can predict those. And that is the power of regression. Now, some important points about doing this. Before you go and do any kind of work on a process, before you try to get knowledge, the first thing you've got to do before you go do regression, you have to remove variability. Because if this process is highly unstable, then what you're going to get, yes, you'll get a prediction equation that looks like that, but maybe the data points fall a heck of a long way from that line. So maybe you get data that's going to get scattered dramatically all over the place. Now what you want to do is get rid of the variability and squeeze that scatter in before you start, so that what you get when you get a good prediction equation, it's close to where the actual result is going to fall. Because you would be very lucky, by the way, to predict a value and land exactly on it. You're not going to have that, but what you're going to get is a little bit of scatter, because that's defined by the R squared. If you have no scatter, all your data points land on the line. So before you start, you could leave the scatter in, but this equation wouldn't be any good to you, because you'd be predicting that you're going to land here, and the scatter would mean you're miles away. So you want to get rid of the variability. So Six Sigma, really, it starts with, let's get rid of the variability. Let's do the basic. Let's go back to this basic principle. Inputs, control, outputs, and variability is the enemy of making money. So if we've got these inputs, what are we going to do before we do anything else? Before we get any fancy mathematics out the box, we are going to fix as many x's as we reasonably can. We are going to put settings in and leave them. We're going to have maintenance routines that we're going to adhere to. We're going to have training that we're always going to adhere to. We're going to have raw material that's always in the right condition. And we're going to remove as much extraneous variability as we can. That's basic, but everything sits on top of that basic procedure. So this always is our focus. Then the maths and the fancy statistics sit on top of that, and they only work after you've done this. They only become useful to you after you do this. By the way, this will probably take you 3 months to do this. So before you jump in and you think, yes, I'm going to do some maths, I'm going to do some fancy analysis, which is what people think Six Sigma's all about. It's not about that at all. It's about this. It's about process control. But once you get process control, the next thing, of course, is process knowledge. And that's what this mathematics allows you to create. Huge amounts of valuable process knowledge with very little effort. That's how Six Sigma works. Process control, process knowledge. And that's part of what regression is all about. It's a super efficient way of getting process knowledge and allowing you to make pots and pots of money.